Hi there, welcome to Unit 3. Unit 3 is called One Variable Statistics. One variable statistics is when you are basically calculating things like mean, median, and mode, and some other calculations just on one data set. So like mean, median, mode, age, height, weight, things like that. Or you might be doing it on two data sets to compare. So you might be comparing the heights of males and the heights of females, things like that. But you're still basically working with one set of data. So the first lesson is really just going to be about some definitions that you're going to need to know for the next 2 units. And there's not really going to be a lot of math. It's going to be mostly reading. And here we go. So what I'd like you to do is to read the first page that talks about some concepts of data. What is data? The role of data and the uses of data in practice. So these would all be really good occupations to be in if you are someone who likes to work with statistics, or if you are going into any of these fields, then you would most likely be taking statistics courses in university. So please read this first page, and when you're finished, so press pause, read the first page, and then when you're finished, go to the second page and we'll go over some definitions. It might help if you make some highlighted notes on this page. So we'll see you on page 2. Okay, well, thanks for coming back after reading page 1. I hope you found some interesting information on page 1. So now what we're going to be doing is going through a whole bunch of definitions. So to start with, the population is the group of individuals or objects that is the focus of the study. The population doesn't have to be people. You could be conducting a study about cars or about medicine or things like that. So population, it's just the objects or the individuals that you are collecting data from. When we collect data from the entire population, we are conducting a census. If the population is too big to conduct a census, information is gathered from a sample which is a smaller selection of the population. So, a variable is a measurable characteristic or attribute Basically, it is what we are collecting data about. So it's your age, your height, your weight, your gender, marital status, annual income, your opinion, etc. So whatever it is you are collecting data about, or basically what question are you asking, that is your variable, or sometimes called the attribute. When we make a frequency table to record data, it would be the title of the first column. The second column generally would have the frequencies, and the first column would have the variable. So, information you collect firsthand is called primary data. So that's basically, if you collect the data yourself, it's called primary data. This type of data is easy to work with because you can control how it is collected. Information obtained from similar studies conducted by other researchers is called secondary data. So for instance, if you got data from the internet or from a book or an article that you read, that would be secondary data. That's data that came from somebody else. Now there's two types of statistics. One is called descriptive, and they are used to describe the main features of a collection of data in quantitative terms. So for instance, if we calculated the mean, or if the median, the mode, if we had two variables and we were looking at the correlation between them, if we took the range or the frequency count, basically if we're making those measurements with numbers, that is descriptive statistics. Inferential statistics is when you make conclusions and make predictions based on the analysis of this numerical data. So that's the difference between descriptive and inferential. Alright, so there's lots of different types of data, and they are often broken down into different categories. So the first breakdown is you have microdata and you have aggregate data. So microdata looks like this. It's just basically you've written out all of the numbers. So if you asked people their ages and you just wrote down 8, 6, 9, 10, 9, 10, 6, 8, if you just kept writing it out, so it is collected from individual objects and recorded. When you take this microdata and you combine it and organize it into a table like this, or some sort of graph, that is what makes it aggregate data. One other thing that I will mention is that microdata is often called raw data, in case you hear that term. Now, the next way data can be broken down is that it can be qualitative, or called categorical, or quantitative, called numerical. So let's look at qualitative. This one should be relatively straightforward. Qualitative is non-numerical data, or data which is in words. So with qualitative, what you have to be sure of is which is the data and which is the frequency. So the data or the variable is always the first column. So the first column contains the data. So these are all words, so it's qualitative data. The second column always has the frequency. So there are 4 people that like peaches, and 4 people that like apples, and 4 that like bananas, and 3 that like pears. So the first column is always your variable, and it contains your data, and the second variable is your frequencies. Now, quantitative data is numerical. Again, the first column contains the data. So if the first column here is numbers, that's numerical, that's quantitative data. The second column is your frequencies. It just means that there were 7 people with a height of 170, 2 people with a height of 172, 3 people with a height of 174, etc. If you look at qualitative data, it can be broken down into 2 different types. So this is only for qualitative. It can be nominal or it can be ordinal. Nominal data is any qualitative data which has no natural order to it. So in this data, you just have colors, red, orange, yellow, green, blue. You can't really put those in order. Alphabetical order doesn't count. So you can't put these in any kind of ranking. Whereas ordinal data, you can put in a natural order. So it's almost like your data can be put on a scale from very dissatisfied all the way up to very satisfied. Or if you had, if you were talking about people's heights and you had short, medium, tall. Things like that, any kind of data that is qualitative, which means words, and it's put into a natural order. How cold is it outside? Freezing, cold, mild, hot. All of that is ordinal. If we take a look at quantitative data, we can break that down into discrete and continuous. Discrete data is data which has a finite number of values. For instance, shoe sizes, you can be a size 8, 8.5, 9, 9.5. You can't be a size 9.25 or 10.3 or things like that. You can't be size 20. You can't be size -2. There's only a certain number of values that you can have. Now, finite means that you are limited to the number of values. So finite means limited. Whereas continuous data is data that has an infinite number of values. Because they have an infinite number of values, your data is often put into intervals. So 0 to 20, 20 to 40, 40 to 60, etc. So you could have values of 2.9, 3.6, 10.45. You can have an infinite number of values, anything from 0 to 20, all the decimals and everything in between. Now you might notice that the 20 is in those two categories. So what would happen is if you had a value of 20, it would go in the higher interval. So you would start each interval with a square bracket, which means that 0 is included, and you would end with a curved bracket, which means the 20 is not included. So this category includes 20, but does not include the 40. This category includes the 40, but does not include the 60. Just like that. And then at the end, this one does include the 100 because you don't have an extra category there. So that's discrete versus continuous. The last two are experimental data and observational data. Experimental data is just data that you collect from conducting an experiment. So here's an experiment where over time they measured the change in water temperature. That was that experiment. Observational data is data that is collected just from watching something happen. So for instance here, the researcher might be watching kids play to decide if gender-specific toys were in favor or if kids just played with whatever toys. So something like that. So I'm going to end the video here for the first half. There's going to be a second half of the video which is going to continue on with the definitions. So please do make sure that you watch part 2 of this video, and it will go over the definitions for sampling techniques and for questionnaires. So please do not forget to watch the second half of this video. Thank you.